angle of friction? Angle of friction is nothing but just the angle between the normal reaction and the reaction force. But there is a condition when here is the limiting friction force is there. Okay, you have to remember. And normal reaction is also a contact force, and friction force is also a contact force now, because friction is there. The significance of friction is there when there is a contact between two bodies na? So I think this point should be clear. So you should remember what is the angle of friction. Theta is equal to tan inverse of mu s. Tan inverse of mu s. So this thing you should know. Okay. Angle of friction. If someone is asking what is angle of friction, so you should know that. Okay. So after that, I have to tell you what is the angle of repose. So basically, angle of repose is the angle at which the block is just sliding, just at the verge of sliding. Basically, this formula you should learn. Angle of repose is equal to, actually angle of repose now is depending upon the coefficient of friction between the block and the surface. More will be the friction, more will be the coefficient of friction between the block and the surface, more will be the angle. Okay, so try to just think it. Okay, this is the condition. Theta is less than theta r. Oh, theta is less than when the angle of the wedge, this theta is less than the angle of repose. Then what happens? There will be no sliding. If theta is equal to theta r, what is theta r? Angle of repose. And what is theta? Theta is this angle, wedge angle. So just about to slide, theta is greater than theta r, sliding is there. So always try to imagine the things by your mind also. Okay. For example, we have done this question. Now we will solve this question. Tell whether the block will remain or stationary. Tell whether the block will remain or stationary. Okay. So this thing we will see. This question. So now what is given here? What is given here in this question? Theta is given. Theta is given. So theta is 53 degree given. Theta is 53 degree given. And how we can tell whether this block will slide or just remain stationary? Either you should take the component of the forces and you should check whether the applied force in this direction is greater than the friction force in this direction, because when the block will move in this direction, or the block will have the tendency to move in this direction. Okay, so limiting force will be in this direction. If applied force is greater than the limiting force, limiting friction force, then this block will start motion. So there is another way also. I have told you this is theta. Now we will find the angle of repose. Angle of repose is given by tan inverse mu s. What is the value of mu s? 0.75. So how can we write 0.75? So this is 0.775. Remove point and 100. So when you will divide it, it will become 3 by 4. Now your angle of repose is equal to tan inverse of 3 by 4. So how can you find theta here? Theta r. How can you find theta r? So this inverse will go this side now. So it will become tan theta r is equal to 3 by 4. 3 by 4, and I have told you that there is a special type of triangle, side 3, 4, 5. Then this angle is 37 degree. So what will be the 3 by 4? 10 theta r is equal to 3 by 4. So what will be the angle for that? 37 degree. So your angle of repose will be 37 degree. Now you can check your theta is greater than, not your, theta is greater than theta r. Okay, theta is greater than theta r. So will this block move or not move? Will this block move or not move when theta is greater than theta r? See, this theta is greater than theta r. So this, there will be the motion of the block. There will be the motion of the block. Okay, so the block will move. Block will slide. Block will slide. Is it or not? This question. Got it, na? Divyangi and Hiba.
Yes, sir.
Yes.
Now we will solve this question. So see here, a block of mass here. This is the mass of 6 kg is placed on this inclined plane, and a force is applied in this direction, and the coefficient of kinetic friction and coefficient of static friction between the surface and the mass is given. Okay, these two informations are given, and this theta is 60 degree. Theta is equal to 60 degree. Okay, we have to find the value of this force when this block is stationary, when this block is moving in downward direction with constant velocity, when this when this block is moving in upward direction with an acceleration of 4 meter per second square. So one by one we will discuss. So answer first. In answer first, we will find the value of the force when the block will remain stationary. When the block will remain stationary. So basically, what is here? This is the surface and this is the block. This is the surface and this is the block. In this direction, perpendicular to the surface, the component of the weight of the block is mg cos theta. And in this direction, mg sin theta. And there is a force in this direction, F. There is a force in this direction, F. And this block is at rest. This block is at rest. Means this block will have the tendency to go in downward direction. Okay. This block is at rest. So this block, in this case, have the tendency to go in the downward direction. So here will be the friction force. Here will be the friction force. Friction force. Okay. And as this block is at rest, so what type of friction force we have? Static friction force. So here will be the static friction force. Here will be the static friction force. Okay. And that static friction force is given by mu s into n, coefficient of static friction into normal reaction. What will be the normal reaction? So normal reaction will be like this. Normal reaction. Now there is no motion in this vertical direction. So we can say normal reaction is equal to mg cos theta. What is mass? 6. What is g? 10. What is cos theta? Theta is 60 degree here. So cos 60. So this is 60 into cos 60 is 1 by 2. So your normal reaction is equal to 30 Newton. So normal reaction is equal to 30 Newton. Now this block is at rest. This block it is at rest means net force on this block in this direction also equal to 0. Okay, so how you will calculate the net force? How you will calculate the net force? So you can say this mg sine theta theta is equal to force in this direction is equal to force in this direction. That is why this block is stationary. Okay, or you can just write in the form of the net force. So this is F plus mu s into n. This is F plus mu s into n. Okay, mg sine theta, m is 6, g is 10, sine theta means sine 60 degree. This F we have to find. What is mu s? Mu s is, see here, mu s is 0.6. So this is basically plus this is 0.6. What is the normal reaction? 30 degree. Now we can solve it. F is equal to, this will become 60 and this is root 3 by 2. So this will become 30 root 3 minus 18. So the answer will be 33.6 Newton. Got it, Divyangi and Hiva? Beta, do you have any doubts, any of you?
Sir, we will not take minus sign.
Where minus sign? Here?
Mg sine theta is equal to minus F.
Mg sine theta is equal to minus of. You are saying I have to do like this. In bracket here it should be minus.
Yes, sir.
Beta, actually na, see here. Yes, I am removing it. Basically, this block is at rest. If something is at rest, I have told you according to the Newton's first law, net force on that block should be 0. So what are the forces on the block? So basically, this block is at rest means neither this block is moving in this direction, neither is moving in this direction. So in this direction, the force is, net force is equal to 0. So basically now what you have to do, this direction parallel to the surface, you can take x-axis, and perpendicular to the surface you can take y-axis. Okay, now if this block is at rest, so I can say that net force along the y is equal to 0, net force on the block along the y-axis is equal to 0. So tell me how you will calculate the net force along y-axis, Divyangi. How you can calculate? In along the y-axis means along this axis, along this direction, perpendicular to the surface of the plane. Tell me, net force.
Yes, sir, I got it. N minus mg cos theta.
Okay, so this is n minus mg cos theta, that is equal to 0. So from here you will get n is equal to mg cos theta. And what is the value of mg cos theta? 30 Newton. Okay, now see, now in x direction also net force on the block should be 0. Okay, so in x direction, see how you will find the net force along x direction. Just tell me the answer. Along the x direction. Either you can take this side as positive, the forces in this direction are positive, or you can take the forces in this direction as positive. So I am taking in this direction the forces are positive. Okay, this force is positive, I am taking this force also, I am taking positive. You can choose any direction. Okay, answer will remain same. So F plus mu s into n, net force in x direction, F plus mu s into n. You have taken this direction as positive, so you have to take this direction as negative. So it will be minus mg sine theta and net force, this whole is the net force, and this is equal to 0. So you can write here uh, F is equal to mg sine theta minus mu s into n. Now you can find the value of the F. M is 6, G is 10, sine theta is root 3 by 2, mu s is, what is the value of mu s? 0.2, 0.6. Mu s is 0.6, 0.6 into normal direction is 30. Okay, again you will get this is 60, this is 30 root 3 minus 18. So you will get the same answer. What is the answer? 33.6 Newton. 33.6 Newton. So I have told you these things earlier, so that is why I am not wasting time. So with time we have to modify our calculation also. Okay. So simple funda I have applied here. Net force on this mass is equal to 0 means force in this direction is equal to force in this direction. Then also na net force is equal to 0 if I am applying, this is a pen. Okay, this is a pen and I am applying a force in this direction and I am applying a force in this direction. So now the force are equal in both the direction. That is why this pen is not moving. If force in this direction is greater, then this pen will move in this direction. If if force in this direction is greater, then the pen will move in this direction. Now Divyangi, clear?
Yes, sir.
Hiba, clear?
Yes, sir.
Okay, so second part we will solve. Second part, moving downward with the constant velocity. So now this block started motion in the downward direction. Downward direction means in this direction with a constant velocity. Answer number second. This is very simple. So this is the block. So in this direction, I have told you what will be the component of the weight. Basically, weight of this block will be vertically downward. This is mg. Okay, this angle is theta or this angle is 60. That is why this angle will also become 60. I have told you these things. So again and again, if I will tell you, it will take lot of time and we will not able to complete the syllabus. I can tell you anything, okay, but it takes time. So there are some things that you have to remember by revising your notes and all that. Okay, so in this direction we take mg cos theta. In this direction the component of the weight is mg sin theta. So there will be one normal reaction and one force is applied in this direction. One force is applied in this direction and this time this block is moving with zero acceleration or block is moving with constant velocity. With constant velocity. If the velocity is constant, then acceleration is equal to 0. What is acceleration? Change in velocity divided by change in time. Acceleration is dv by dt na. So dv is the change in velocity and this velocity is constant, so acceleration is equal to 0. Now again there is a point here. The acceleration of the block is equal to 0. So can anyone tell me what will be the net force on the block? Fast. Tell me fast. If acceleration of the block is equal to 0, Divyangi?
0.
Yeah. If acceleration of the block is equal to 0, then what is the formula of the net force? Net force on the block is equal to mass into the acceleration of the block. So net force on the block is equal to mass into 0 is equal to 0. In this case also the net force is 0, but this block is moving. So can now tell me this block is moving in this direction. So what what is the direction of the friction and what type of the friction will be there? Static or kinetic?
Kinetic.
In this direction, there will be a friction force, and that friction force will be the kinetic friction force, and kinetic friction force will be given by kinetic friction force will be given by coefficient of kinetic friction into normal reaction. Now normal reaction is equal to mg cos theta. Now do we have to do fast now? We have to do fast, otherwise normal reaction is equal to mg cos theta. So mg cos theta, what we got earlier, 30 Newton. You can do this, put m6 g10 cos theta 60, you will get your answer. Now net force in this direction also is equal to 0. So how you will equate the force? So force in this direction is equal to force in this direction. So what is the force in this direction on this block? Mg cos theta, mg sin theta is equal to F plus Fk. F plus Fk. Now we want to find this F. So this is mg sin theta minus force of kinetic friction. Now m is 6, g is 10, sin theta is root 3 by 2 because theta is 60 degree. Kinetic friction. So for the kinetic friction, you will write mu k into n. Mu k is given as 0.4. So you will put here 0.4 and normal reaction is 30. So it will become 30 root 3 minus 12. The answer will be 39.6 Newton. So what will be the force this time? 39.6 Newton. Okay. Now third part. Now this block is moving in upward direction with an acceleration 4 meter per second square. Acceleration 4 meter per second square. So third part. So this is the wedge and this is the block, and this block is now moving with an acceleration of what acceleration? 2 meter per second, 4 meter per second square. 4 meter per second square. Okay, so in this direction, mg cos theta again, perpendicular to the plane, the component of the weight will be mg cos theta, and in this direction, mg sin theta. Now, there will be the normal reaction also, and this block this time is moving in this direction. This block is moving in this direction. So this time this block is in motion, so it is clear that there will be the kinetic friction, but the motion of the block will be in this direction. And what is friction? Friction opposes the relative motion. So this block is moving in this direction, so friction force on this block will be in this direction. Okay, in the opposite direction of the motion. And friction force will be kinetic friction force. Friction force will be kinetic friction force. And there is another force F also. Okay, there is another force F also, you can see here. This is this force we have to find. Now what we will do in this case? Now can you tell me, is there any motion in this direction? No, there is no motion in this direction. So normal reaction is equal to mg cos theta. So what is mass? 6, g is 10, cos theta means cos 60. So when you will solve it, you will get 30 Newton. Now this block is moving in this direction. This block is moving in this direction. So we have to calculate the net force on the block is equal to mass into acceleration, Newton's second law. So what will be the net force on the block? So for calculating net force, you have to take this force as positive, this force as negative, and this force as negative. Okay. So net force will be F minus mg sin theta plus Fk is equal to, this is equal to the net force on the block, is equal to mass into acceleration. Mass of the block is 6 and acceleration of the block is 4. Acceleration of the block is 4. Now it is so simple. This is equal to 6, this is 24 plus mg sin theta plus Fk. Okay, so solve it. 24 plus, okay, so both of you uh, solve it by yourself and tell me the value of the friction force. Just try it by yourself. Find the value of the force. $87.9. I am getting 87.6. Okay, your answer is correct. Hiva, have you completed this? What answer you are getting?
20.
Hmm?
Yeah, 24.
Okay. So basically, na, you have to just add the things. Okay. Here. Hmm. This is very easy task. Okay. See here. This is mg sin theta. Na. What is m? 6. G is 10. We are taking sin theta is sin 60 degree. Fk is mu k into n. Okay, so this is 24 plus this is 60 and this is root 3 by 2. So this will become 30 root 3 plus mu k is 0.4. Normal reaction is 30. So this is 24 30 root 3 plus this will become 12 and root 3 you can take 1.7. So this is 24 plus 1.7 into 30. plus, so this will become 36. This 24 and 12 is 36 plus this will become 17 3 51. So I think you will get approximately 87. Okay. If you will take 1.73 here, then your answer will be there will be variation in the answer. So you will get at least 86, 87.6 at least you will get. Okay. So so when you will take 1.73, then your answer will be, so it is better to take 1.73. Okay. So when you will take it, you will get answer at least 87.6. Okay. So and Newton also. Write the Newton also. Okay. Otherwise, your answer will be incomplete. You have to write the unit of the force also. Otherwise, your answer will considered as incomplete answer. Okay, so write down first this question. Yellow color things will represent the solution basically. Write down fast. So basically, yesterday in the last class, I have told you this question. So completed. Okay. Hiba completed. Hiba completed.
Yes, sir.
Now write down this. So remember this triangle. This triangle, there is one more triangle, right angle triangle. There is one more right angled triangle. 4 3 5. So in that case, this angle become 53 degree. If you have completed, you can write just small d in the chat box. Okay. Okay. Divyangi and Hiba, are you from some Middle East country like Arab and all that?
No, sir, India.
You are from India.
Yes.
You both are from India, me Hiba and Divyangi.
Yes.
Okay. Kiss. Okay, so should I scroll down now?
Yes, sir.
So after completing the class, when you have a time, okay, when you have a time, so practice these questions by yourself. Take one paper, take one paper or copy, and see only the question. Don't see the solution and try to solve that question by yourself. Okay, no matter you are doing a wrong, no matter you are doing a right, but at least you should try it by yourself, because in the exam, you know, you have to solve the question. If I am telling something, that is different, but when you will solve, then that thing will be different. When I will solve it, then you will think that so sir has solved, this is very very easy for me. But when you will solve, then you will face some difficulty, definitely. I know. And there is no other way to learn physics rather than to solve the questions. After that, there will be a topic, block on block. So that topic is little bit complex for the students, but I will try to explain in a way that you will feel it is much easier. Okay. Completed.
Yes, sir.
Okay, so write down this second part. Okay. Okay. Hiba, you also completed?
Yes, sir.
Okay. Now see, we will discuss a topic. Uh, hmm. Suppose, see this. Suppose this is one block. You can imagine this as a block. Okay, or it is better to take this. Mm, This is one block. This is one block, and this is another block. Okay, so mm, so basically, oh, now it's okay. Okay, so this is the surface, no? This is the surface. This is the surface, and on this surface there is one block. Actually, for the block, I have to take this. Hmm. So basically, this is a surface, na? This is some surface, and this surface have some. This is a frictional surface, not the smooth surface. This is the block. This is the one block placed on the surface, and this is the another block placed on the surface. So this is the condition. You can see here. Now, what can happen if I am applying a force on this block, downward block? So if I am applying a force, suppose like this, so both blocks are moving together. Both blocks are moving together. But when I will apply a very large force, I will not do because this is my phone. Okay, when I will apply a very large force, then this block will move alone, and this block will not move. Basically, there is a relative motion uh, between this block and this block. Okay, there is a relative motion between this block and this block. But when I am applying a small force, you can see both blocks are moving together. But there will be a force. I know that. Believe me, I am telling. If I will do that, my phone will be there. So that's why I'm not doing that. So this will be there will be relative motion at a particular value of that force, and that force will be the maximum force at which there will be relative motion between these two blocks. And there can be any other condition also. If I am applying a force on this block, upper block, so there can be two possibilities: either two blocks should move together, or either only this block move together. So basically, we are interested to calculate what will be the maximum value of the force applied on the either block, so that both the blocks will move together. And one thing more. Basically, this is the surface, so there is a friction between uh, this block and this surface, and there is a friction between this block surface and this another block. So we have to keep in mind these points. Okay. So there are few steps to solve this type of problem. Okay, and I have already written the steps to save the time, but we do not have the time. It's so basically block on block question. So this is one block, this is another block. Here what I am doing, I am applying a force, some force on this block. Suppose this block has mass m2, this block has mass m1, and I am applying a force on here. So here is a coefficient of friction between these surfaces, coefficient of friction mu1 between these surfaces and mu2 between these surfaces, and we want to calculate the maximum force apt such that both blocks move together. Okay, so steps are there. Okay, I have explained you what will happen. So basically, first you will find the limiting friction on both the surfaces. Limiting friction means maximum static friction mu s into n. Between the both surfaces, you will first find the limiting friction. After that, you will search that block which will have only friction force. You will search that block which will have only friction force, means this block have some external applied force also, but this block will have only friction force. I will explain in the next class. Okay, and such that block which has only friction force. So basically this block we have selected which has only friction force, and after that find the maximum acceleration of this block. So after that we will find the maximum. How we will find the maximum acceleration? By putting the limiting friction force. With the help of the limiting friction force, which basically we will get the maximum acceleration of this block, and we will use the acceleration of this block in this block to calculate this force, and that force will be the maximum force, so that both block will be maximum applied force, both block will be moving together. If we have applied more than that maximum force, then there will be a relative motion between the both the blocks. Okay, so